GCSE Physics boosters, momentum. This fella here, Jonah Lomu, he's got loads of momentum at the moment. Now, a moving object like this aeroplane is moving. Now it's got mass, it's got velocity, it's got acceleration, it's got kinetic energy, and it has momentum. Now look at the units of momentum, kilogram meters per second. Okay, don't forget that, kilogram meters per second. So what is momentum? How do we work it out? And why is it useful to know what the momentum of something is? The last one we won't worry about for a few slides, but how do you work out momentum? Momentum is mass times velocity. So the mass of the object in kilograms multiplied by its velocity in meters per second, and we use the symbol P for momentum, and I haven't got a clue why. So P equals mv. For example, this dog, 7 kilograms, 5 meters per second, 35 kilogram meters per second. One important thing to remember about momentum is that it's a vector. In other words, it has direction. If you look at the first dog, now if I'm taking left to right as being positive, so that dog's 35 kilogram meters per second, this other dog is minus 20 kilogram meters per second. Why is it negative? Because it's going in the opposite direction. So just like velocity and acceleration and displacement, momentum is a vector. In this case, it means it can be positive or negative. Remember that. Here's just a couple of quick sums for you to do. If left to right is positive, how much momentum do the following objects have? Have a go. Show you the answer in 3, 2, 1. There you go. Okay, might be some problems with units there, but basically there's your momentum, and some are positive, some are negative. Okay, so why is momentum useful? Well, knowing the momentum of an object isn't particularly useful. What is useful is when you've got several objects involved, when you've got a system of objects. Okay, consider this: you've got a van driving along at 10 meters per second, and you've got this Mini traveling in the opposite direction, and they're in neutral, so their engines aren't involved, they're just trundling along, and they collide head on. Now, nobody gets hurt. Anyway, after the collision, what direction will they be moving in after the collision? Have a little think. What direction? Left to right, or right to left, or dead stop? In fact, I'll give you a multi-choice. Which of them, after the collision, immediately after the collision, which of those will be correct? And kind of common sense, I think, should tell you that it is that one there. Okay, now why? Well, basically the lorry, the van, has lots of momentum in that direction. The Mini has less momentum in the opposite direction, and what we're doing is we're adding the momentums together, the momenta together, and you're going to end up going left to right. Conservation of momentum. For any closed system, the total momentum before and after any event, for example a collision, must be the same. Momentum is conserved. The momentum before equals the momentum after. Okay, momentum is conserved. Why? I'll worry about that later. It's actually to do with Newton's third law. But so how did I get 4.4 meters per second? Well, I'm actually going to work this out for you. So we have the momentum before. Now the van, its momentum is 1,600 times 10. That's its momentum before. The Mini, now I'm going to say minus because its momentum is negative. and that's minus 850 times 6. And if you work that out, that is the total momentum before. And that will be equal to, now, if we consider this as being one object, then the mass of that object is 1,600 plus 850. I'm using my mouse here. Okay, times the velocity of that object. Okay, and if you work that lot out and divide it by that, you get 4.44 meters per second. A closed system just means that there are no other objects involved. There is only the van and the Mini that we need to worry about. No other objects are involved. It's a closed system. Here are some sums for you to have a go at. Probably take you a while, so pause the video, have a go at them. No cheating, pen, paper, calculator. I'll show you the answers in 3, 2, 1. And there you go. Work through the answers yourself. Now, I said for a collision, but for any event, look at this boy with a ball. And now he stood on a skateboard and he throws the ball. What happens to the boy? Well, what will happen is that the boy will move in the opposite direction. Now, why? Because the total momentum to start with is 0. And so if the ball gains momentum that way, then the boy must gain the same amount of momentum that way. The total momentum is 0. Okay, so momentum before equals momentum after. So 0 equals 5 times 5, which is the ball, minus 60 times v, which is the boy. And if you work that out, you get v is minus 0.42 meters per second.